Okay, let's go ahead and get started. Just to remind you guys kind of where we are, we finished our Checkpoint 2 FedEx presentations last week. And so that puts us here. We have, okay, yeah, those are I think those are Sundays. Maybe Mondays? I don't know. Those days are just indicating the week. Anyways, here we are today, April 2nd, and quiz 6 is due on Canvas. If you haven't submitted it, please do. I've noticed a lot of people have been submitting it, but I don't know overall where we are. It's real easy, so please do that before midnight. Today we're going to talk about HCI research and studies at a broad level. And then Thursday, we will start looking more at designing and conducting a user study, some of the specifics. And then next week, we will finish up that by talking about how to analyze data from those studies. I'll post either, I'll probably post it tomorrow, a homework 3, and then I'll change that so that it's not due a week from today, but it'll be due a week from Thursday. So we'll have that homework, and then we'll have one more after that. And so quiz 6 is helping inform how we fill in these 2 lectures. So I've looked at a couple of responses a few days ago, and there are a lot of good ideas and a lot of good questions, and I hope I'll be able to answer all of those. Let's see what else. I do apologize for not having a lot of your stuff graded and posted to Canvas. I've been having a bit of a crazy past couple of weeks. We've been trying to get one of our robots into a state that it could be shipped to Australia and survive that trip and then work reliably once it got there. Where no one has tools to repair it if certain things go wrong. And so that's consumed quite a bit of my time, and I have not had time to actually sit with Canvas and input things. I hope to do that either this afternoon or tomorrow, because that robot finally shipped yesterday, and it was a glorious moment, because I cannot even begin to convey to you the pain and the struggle there. But so I will work to get all of your stuff back to you. I'm almost through with your exam 2s that everyone submitted, and overall really good. And we'll talk, I guess maybe next week, about the potential of maybe doing exam 3 as a take-home as well, because I think most people enjoyed that, and most people felt pretty good doing it in that style, and I'm okay with that, and I think we could set that up, but we'll talk about it as a class and decide what we want to do there. Also, just want to mention, in terms of your group projects, a variety of groups have either talked to me about, or I've noticed that maybe not everyone in the group is working or communicating as well as they should. And this is not uncommon with group projects. We all know this, right? We've all been in group projects. And what I would stress to you is it's really important that you at least communicate with your group members. I understand, and I encourage you to be understanding that people have other things going on. Sometimes we have, just life circumstances that aren't great. Sometimes we can't contribute the thing that we said we could contribute. If you communicate, and you communicate early, that's always better than just disappearing from your group or not informing them. It's kind of like in here, if you guys can't be here, or if you miss a quiz but you had something, and you email me and you just let me know, it's no big deal. We can just make it up. It's not a problem. We don't have to have a rigid rule structure, but it's a nice thing to do, to communicate with your group. and it will help things go better. You'll all get the chance to give peer feedback on your groups, and I just encourage you to really contribute to your group in any way that you can. And it's not too late. If you've been the person who's just kind of been, not there or not able to do stuff, it's not too late to talk to your group and try to, contribute something. And also, if you're in a group and you're kind of like, you feel like you're the sole fighter trying to get a project done, which I don't think is the case for any of us really. But I would say, please come talk to me if that's the case. Don't overwork yourself. Don't let it affect your health negatively because you feel like you need to do a whole project on your own and your group members are just missing. Let me know, and I'll try to help you find your group members. And if you have anything else group-wise or with your FedEx projects, let me know, and I'll try to help the best I can. So, before FedEx projects, we talked about non-traditional user interfaces, covered a wide range of things there, and I think we'll probably touch on a few of these again in some of those lectures based on some of the feedback that you guys have given about what you'd like to see us talk about before the semester is over. But today we're going to talk a little bit about HCI research and studies and evaluating interfaces and products and systems that you develop and kind of why that's important, how we go about doing that, and really touch on some of the high-level details. And what we'll do today is we'll focus just on the overall process, and then the next two classes we'll focus one class on designing studies, and then another class on analyzing data. And what you'll kind of see is that this is just a cycle back and forth here that overall helps you evaluate the thing that you're building and design the next version of it or refine the first version of it if you haven't done that. So talking about evaluation in general. So evaluating the thing that you're making is a huge part of the design process, and we've talked about it pretty much from the beginning, from when we started doing sketches and prototypes and all the way through, getting feedback, whether it be from just people on the design team or casually or informally from someone looking at your design, or running an actual more formal study or effort to evaluate it. It's useful because it lets you see what's working, what's not working, you might point out things that you didn't think about that deserve further investigation. And we certainly see this kind of when we talk to FedEx with these checkpoints, right? You present the things that you've done, and then they give you some feedback. And it's, for the most part, there's usually at least one or two things that maybe, at least I know when I watch them, I'll watch your presentation and I'll think of certain things, but then they'll mention something that I totally didn't, even notice or think of, and it'll, be something interesting for them and something interesting for you to think about. And so that's part of just the design process in general, is this evaluation loop. So it is the feedback on your design. And as we've seen, the scope and the purpose of evaluating a product or a system that you're designing can vary. So we talked earlier this semester about usability versus user experience. So one way to evaluate something you make is, does it work? Does it do the thing that it's supposed to do? If it's, the FedEx, like the Dropbox diagnostics app, does it tell them the battery level? That's a pretty easy thing to say. Does it do it or not? That's a usability criteria. But you can look also at user experience. And this is certainly where we see things today for a lot of products. looking at the thing that you've made and what that does for the experience of the user. And so in order to do that, you have to have some way to capture and quantify user experience in terms of the thing that you're making. And that turns out not to be such a straightforward or easy thing to do. It's certainly, you can capture a lot of basic things easily and intuitively, but there's a lot of nuance involved, especially when you start to look at user experience and the very specific things that a user encounters during their interactions with your product. So as we talk about this, I'll try to give you a little bit of each side here. So there's going to be the academic world when we talk about doing user studies and evaluations and research. And then there's actual industry, actual commercial applications and products that are being sold to consumers or businesses and being used. And the techniques and the approaches are very similar in these two worlds. What differs mostly is kind of the motivations, I guess, and the ultimate uses for the things that are discovered during this process. So in the academic world, people doing HCI research tend to be motivated to figure out, we've got this interesting new interface or device or theory about the way that people, think about something and manipulate something in a system, and the kind of the motivation is an overall concept or theory about how something operates, and the idea is to find kind of general principles and the exceptions to those principles, and to see to identify more about human-computer interaction or human-machine interaction in general, in a way that it could be applied to many specific products or implementations. In industry, this is certainly the case too, but a lot of times in industry, you'll be doing work on a very specific product. We make this thing and we're interested in specifically how it can be made better for a user. And the outcomes are not necessarily a theory or a principle. They can be as simple as, we want to increase user engagement with this. We want to sell more of these. We want it to appeal to more groups. So it can be a little more straightforward and linked to a very specific thing in industry. And that's not to say that industry doesn't look at broader things as well. They certainly do. The other difference that we see between the academic world and kind of the commercial world is that in the academic world, the main purpose of doing evaluations, of doing investigations and research, is to kind of come up with these findings, gather this data, and to write about it and publish that, and to have it reviewed by other people who are experts in the field, and then to make that data publicly available so that it can be built upon and used further. Luckily in the field of computer science and in HCI, we see that people in industry do this a lot too. So if you go to an academic conference, in like a HCI conference or just any computer science conference, there's a good chance you'll find people from Facebook or Amazon or Google, or finally even Apple allows their researchers to publish the results of what they're doing. Now, they certainly don't publish every study they run, and they don't publish all of their data because it can be a tremendous competitive advantage for a company to have certain insights and certain data. When you run studies and gather data, you can also kind of tip competitors off into what you're thinking and what you're interested in. So we see that the academic world is definitely centered around, putting the data out there in the world, whereas the commercial world is definitely open to that, but in a more constrained way and on a different timeline usually. So the academic focus is usually on a more narrow area of new technologies or approaches. So whereas if you're developing a product or something that you're going to sell, you may want to investigate all aspects of it. You want to make sure the system you build is comprehensive and working. In the academic world, we might care about something very specific. For example, in my lab, in a study that we did, we care very specifically about the gender of a robot and its voice. Nothing else matters to us in that context. And so we may go through a very complex study where the user does a lot of other things interacting with the system, but the main thing that we care about is just that voice and what the differences are based on that. And the main purpose is for further understanding and evolving our approaches. And kind of one of the things in the academic world that's really big is that you're going to face a rigorous review of what you've done. So when you evaluate something that you've made, or you're going to make a claim and support it with data, the way that works is you will develop your system, you'll build it, you'll design your study, you'll run your study, you'll gather your data, you'll analyze the results, and you'll write it all up, usually in a paper that is, probably anywhere from 8 to 20 pages long. And that paper then gets sent off to usually 3 or 4 people who are experts in the area that you're contributing to. And in computer science, in HCI, we have 2 main ways of doing this. We have academic conferences, which are usually annual events that happen. And then we have academic journals, which publish usually on a monthly basis. So if you're writing a journal article, that is usually a much longer piece of work with a lot more data and a lot more analysis. And it's reviewed very thoroughly. In computer science and HCI specifically, conferences are usually shorter pieces of work, usually about 8 pages long, and they are actually reviewed pretty thoroughly. So in a lot of fields that are not computer science, conference papers or things that are submitted to conferences do not undergo what's considered like a rigorous peer review process. That's not the case for a lot of computer science and especially HCI. So when you submit your work to an HCI conference, it will get reviewed by 3 or 4 people. They will send you back their comments and their recommendations, and then you will have a chance to give a rebuttal to those comments and try to convince them that you can fix whatever is wrong with it, or argue that you can revise it to better explain yourself. And then a committee will ultimately decide which papers are published in that conference. It's a very competitive process, and it's very demanding. For a journal in computer science, it is a similar process, but the feedback that you get is much more extensive, and it can take months to get through the process. So a conference, it's usually a month or so from the time you submit it until the time you know if it's going to be published or not. With a journal, I've had journal articles where I've spent over a year going back and forth with reviewers doing revisions. And so one of the reasons that the computer science conferences specifically are more rigorous is because computer science as a field does move pretty quickly. So by the time a journal article is published, a year or 2 has passed since you did that work. It's not exactly the thing that everybody's interested in necessarily. And so that's that's different. But the main thing is that these publications are essential. And if your job is in the academic world, publications are kind of a measure of your value and success. So these are the things that you're going to get judged by in terms of advancing in your career. Sadly, not getting good teaching reviews. So it's probably why you've had some classes where it seemed like whoever was teaching you was kind of just annoyed they had to be there, because for them it really pays off to get the research done. But not me. I'm very happy to be here. So the industry process is typically centered around a business interest, which makes sense. So rigorous approaches are not always necessary in industry. Really, you want to do what works, right? You want to do the thing that gets you a usable system that people use and buy, and that works for the company. And so, obviously, we'll talk about the rigorous approaches and doing these evaluations. They're usually very beneficial. Like, it's usually very much worth it to do a good job planning your evaluations and to be thorough with them. But because in industry you're not always going to have these peer reviewers, these experts looking at it, you don't necessarily have to be as rigorous. The other thing is that a lot of findings from industry are not always publicly available or acknowledged. And that's what I mentioned that earlier. Just from the fact that there are a lot of things where a business is investigating new areas they might want to go into, or they're looking at things that they're not quite sure how it's going to affect their public image or something like that. And we've certainly seen instances where companies have allowed their researchers to publish things, and that backfires because once people read about it, they're like, oh wow, Facebook is watching its users and manipulating what they see to see if it makes them happier or sadder. Well, is that an ethical problem or not? Okay, so it probably would have been great for Facebook if they just hadn't published that paper, but it's nice that they did. But this is something that they definitely, there's a risk management side to this. So a large company is going to have a legal team that's going to be reviewing things. And also if you're secretive about your product roadmaps, and most companies are, you may just not want to be part of this. So Apple got criticism for a long time because they didn't allow anyone to publish at Apple. Okay, so like their machine learning research that they were doing, Apple's machine learning researchers would go to all the conferences and basically not be able to really tell anyone what they're doing. And so people were kind of like, hey, you're not contributing to the community, and so that's changed recently, within the past year or so, where they do publish now. And so I should say a lot of companies are strong contributors to what academic conferences and publications, and just putting things out there in general. So a lot of tech companies have nice blogs where they'll talk about developing a product or what kind of testing they did. In general, our industry is more open and more willing to share. So thinking about why we should evaluate systems at all, I think there's some pretty obvious answers here. The first one being, if you're building something for someone, you want to make sure that it does the thing they need it to do. Otherwise, they're probably not going to ask you to build anything else. And if you are directly selling it to users, then you want to make sure that your product is kind of the best that it can be, and that they're going to continue to use your product and recommend your product, and that you're going to gain more users. The other reason is you can identify problems and unforeseen issues either early on, if you're evaluating, as you're developing new features, or even later in the process. There may just be things that you haven't thought about. and that even though you're on a design team and you're very focused on the area that you're working on, and you're very well informed, there will just be things that don't come up when you're using it, when your design team is using it, and then you'll have a user sit down and some fundamental question will just appear, and you're like, wow, okay, we didn't think about that. And that's really where evaluation pays off. And it also pays off in terms of generating ideas for what you're going to do next with your system if you're working on something that is continually evolving, which is the case for a lot of products. A lot of the best ideas, and even in academic research, a lot of the best, I guess, ideas about where a particular research direction will go, or what's something that hasn't been looked at yet, come from a little comment that someone makes in a study or while they're evaluating it, or a behavior that you see across a number of people that's odd that you didn't expect, and that can really prompt you to develop a whole new aspect of something, and to investigate that further. Another thing that evaluation helps us do is it helps us make informed decisions with data. And in general, just in life in general, we should always seek data and some kind of truth or fact-based, evidence-based support for the decisions that we're making. So, a design team can sit around and argue all day that, I think it should be this way, you think it should be that way, to me this is intuitive, to you this is intuitive. A great way to settle debates like that is to test it with a group of people that's not the design team, and see, what do the numbers show, what needs to be done, and to really help the designer understand the user's perspective rather than our perspective. And so this does provide guidance whenever our opinions differ. So in terms of what we should actually be evaluating, you can do this in any scope, right? So I talked about the robots and looking specifically at a female voice or a male voice. That's a very specific feature that we cared about in that instance. You can also look at broader, more holistic workflows. So I could look at someone interacting with a robot, and I don't necessarily care about every little movement that it made, every little thing that it said, but I care about how they felt at the end of the interaction as a whole. And I'm not going to try to analyze exactly every little detail of what caused that. So you can look at that at different levels. And a lot of times, what you're going to evaluate really depends on what you care about, what you need to be informed about better, so things that you're unclear on, and then kind of whoever's paying the bills or paying you, what are their motivations? And in a lot of cases, that might be your direct user. You might be the sole designer developer creating something you're selling on some app store, and the stakeholders are the people you're selling it to, and you want to solve a problem for them in the best way possible. So establishing a good user experience, pleasing users, those are often good motivators to show you what you should be evaluating. So you also might be interested in doing something like changing a user's behavior. And so that may cause you to evaluate a totally different set of things. And we'll start to talk about how we evaluate things, how we measure these things, and you'll see that we may measure different things depending on what our goals are here. You may want to, if you're most companies making kind of like the most popular systems that are used. You want to increase engagement, right? You want the user to be spending their time in your app, on your platform, and that indirectly will increase usually your value as a company or increase your profits. And another thing that we often want to do is we want to understand kind of user traits and behaviors. And so there are a different set of things we might evaluate if we're focusing on better understanding our user rather than trying to change our user. And these also vary depending on when you're evaluating. So if it's early on prototyping phase, certainly like understanding your user and their behaviors is really important early on. So talking a little bit about where do evaluations happen. And so we'll go into more detail about this next time when we talk about actually designing these studies and these evaluations. But there are several different places that an evaluation can actually take place. So I've broken them into two major categories here. So we have controlled environments, and these are like research labs, whether that be at a university or at a company. And these environments are tightly controlled. You bring people in, so you're shaping a lot of what's going on. You're able to manipulate a lot of variables reliably. Another controlled environment can be something like a focus group, where you're bringing in a group of people, but you're going to be kind of talking to them and guiding the conversation. Then we also have natural settings where we can do actual evaluations. So one way of doing that is just observing what a user does with the system in its natural context. And in a lot of cases, that may mean kind of just tracking what they're doing in the background, and we'll talk about that in a little more detail. Also, in natural settings, we can do things like remote surveying. So you can send the user a survey, asking about their experience with a certain product. And I'm sure we've all gotten that at some point or another from some service that we use. And the user can give you some feedback. And so obviously in these cases, the user is not in a controlled area. They're just kind of out where they're existing. And you can do this also kind of in the background. This is certainly the case for most of the applications we see on our mobile devices and even on our desktop computing environments now. A ton of data about what you're doing is being collected and sent back for analysis, where you're clicking, how long you're there, kind of all of that behavioral data. And that's being collected while you're using the system in the natural environment that the system exists in. So when do we do evaluations? Obviously, throughout the design process. So if we're building a commercial product, usually we'll do some evaluations early on before we actually develop the product. At various phases throughout development, we may do very specific evaluations for certain features. We may do broader validations to say like, hey, is this thing still usable? Is it meeting all of these goals? Is it checking the boxes? And then more so now, we also do this in an ongoing fashion after we've launched a service or an application. And this can also be done without having to do a ton of special work at letting the user know that you're doing this necessarily. So A/B testing is very common, where we'll just give two different versions of a feature to a subset of users and then see how that affects how they interact with their application. So that's certainly the preference for a lot of major services that exist today. In the academic world, it's similar in terms of when we do evaluations. So usually in an academic world, a researcher or a lab of researchers will have a certain focus, a certain area that they're interested in. So the lab that I work in is interested in social and therapeutic robotics. That's a really specific area. And so if we're looking at something within that area, we're going to first, so say that we're looking at the idea of, using a robotic therapy animal with people who would usually use a live therapy animal. The first thing we're going to do is some type of proof of concept, or just confirmation that this is something that is worth investigating, and to give us some idea of what needs to be investigated specifically. And then as we get further and further in, we continue to run studies and evaluations on the thing that we develop. And in the academic world, that may not just be, we may not stick with one product or one platform. It may branch into other things, kind of serving a unified purpose or answering a research question. That's just an overall theme, basically. So, okay, the how of, how do we actually do these evaluations? So there's a lot of different types of studies and evaluations. We've mentioned a couple of these already. Passive observation is a big one in terms of analytics and just watching what a user does with a piece of software, if we can. Focus groups are also big in the early phases of developing something, just talking with people, asking them what their expectations are, how they would feel about this or that, kind of just gauging what people think about the area. Ethnographies are another great way to understand what a set of users need. We talked about this earlier in the semester, but the idea being that you would go as a system designer or developer and spend time with the people in the context where they would use your system and just see how they do things. So at one point we were writing an application for Toyota to help them better manage their assembly line. So we went, a few days and just spent time with them on their assembly line, just, following this group of people around and seeing how they were doing the thing that they were doing that we were going to augment with a different application. Another way that you can do this, field experiments or just field observation, is a really nice way of doing things. So we'll talk a little bit more about this, but if you bring people into a lab, into a controlled environment, you've already created kind of a different setting compared to where they're actually going to use this thing. And that's going to affect what you measure. So part of developing the lab study is there's a lot of work to try to make sure you haven't done something just by bringing them into a lab that's going to make your results meaningless when you actually have this thing in the real world. And so we call that ecological validity. So do our findings hold in the natural environment that this thing is going to be used? And so field experiments are a great way to maintain ecological validity. The idea being that you go out to where this thing is going to be used, and you either watch it being used or you manipulate characteristics of it while it's being used. In robotics, a big interesting type of field experiment is just to take a robot to a public place like a mall, or we've done studies where we have them just out on the drill field doing things to see what people do with them, how they interact with them. And then, of course, controlled experiments are pretty much the gold standard when it comes to a lot of scientific work and a lot of work that's going to be published and used later to be built on. So talking about passive observation and analytics. So this is very popular, commercial software. So just pure user behavior. What are they doing with the system I developed? Where are they clicking? How long are they looking at certain things? And there are a ton of products and frameworks available to help you do this in a software application. So pretty much any website you go to will have some type of analytics tracking on it, usually Google Analytics. It's just telling the website owner, who's visiting the site, how much are they looking at this, where are they clicking, what are they doing. And the nice thing about something like this is that it does happen in the background without the user's awareness. We'll talk about the other side of that in just a second. But it limits bias because the user is unaware that it's going on. They're not changing the way they use your service because you're measuring it, because they don't realize that it's being measured. It's not affecting their interaction. The limiting factor there, though, is that we have to infer things once we have this data, because we didn't directly ask a user, why they were doing something. And sometimes there are ambiguous situations, and sometimes we can make the wrong inference about why we're seeing a certain pattern in data. And so that's a huge design issue in terms of how much data we collect and how we can be sure that our inferences are correct. Now, on the other side of this is ethically challenging at times. For me personally, over the past few years, it's been really upsetting to see that every application that I use is trying to send back data to whoever made it about everything that I do with it. And I'd encourage you, if you haven't used your computer with a network monitor active just to see all of the incoming and outgoing packets, do it. You'd be surprised. Every single thing wants to send some kind of message back home, usually. Microsoft came under some criticism for this a couple of years ago when they really started pushing telemetry in Windows 10. And to this, currently, they still push it heavily. There's, every little thing they want to know about. Now, there are ways to do this where you can help ensure a user's privacy and still gather this data. But that is a trade-off because the user has to trust you that you're going to do that properly. And you have to have confidence in yourself that you actually can do that. There have been a number of instances where companies thought that they were doing a great job of providing privacy and still collecting analytics, only to find out that they weren't. So one that comes to mind for me is that Netflix several years ago had a challenge where they wanted people to write machine learning algorithms for them to help recommend movies. And so to help people do that, they provided them with a data set that Netflix had of movies that their customers had watched. Okay, and Netflix thought that they had anonymized the data pretty well. It turns out it wasn't that hard to put that back together and to find out, some very specific things and find out pretty much who these people were. AOL, America Online, had a similar thing happen when they decided to release a data set of web searches that people had run. A lot of sensitive information goes into a web search. This kind of thing can be very dangerous. And it can make users upset. I will say in general, a lot of users don't seem to care that much. The outrage does not last that long. But I think it's part of what you should consider when you're doing this, the ethics of it. And certainly if you're going to run evaluations in an academic setting, and even in a lot of industry settings, you will have to spend a lot of time getting ethical approval and oversight from a review board to do this. So moving on, focus groups. These are really simple. Basically, we get a group of people together. We talk about the product or the service, get their ideas, get their feedback. These can be quite time-consuming to conduct and analyze because the data that you're going to get from everyone is going to be verbal data, written data, it's qualitative data. Then you're going to have to take all of the things they've said and somehow make that usable in designing a product. So it takes a lot of time. Biases can often be hard to avoid here because you're going to have someone in the room with your participants, with your users, helping to guide the conversation. And a lot of times, even if we try not to, there's a lot of social conventions that we follow as humans, and we try to be nice to people. And certainly if we think we're talking to someone who's making something and we don't want to be rude, or sometimes the opposite, sometimes we're very aggressive. But these biases can really affect what does this data actually mean for us. And so that's hard to avoid. Also, if you're doing a focus group, usually a clear leader will emerge of the group, and then everyone will just kind of follow that person's opinion. And so that's something that has to be managed as well. Field studies, really great for understanding how something's actually used in context, so that ecological validity problem is avoided. But it can be logistically very difficult to do this. It's very time consuming, and a lot of times you can't completely eliminate the fact that you're there. So like when we were with Toyota, watching their process, I can guarantee you there were things they didn't do those days that they probably do every day, because they had outside people there observing, people who weren't part of the group. You can really commit to this and spend years with a group and really become part of the group and eliminate some of this bias. But then you also have to worry that your biases have changed as well. So that's kind of the downside to the field study. So to give you some examples, these are things that we do in our lab. We do a lot of social therapeutic robotics, but we also work with law enforcement, doing a lot of work with them and using tactical robots. And so one of the things we do is we do these monthly trainings with Starkville Police Department SWAT team. And the idea is to understand how they would use robots as a law enforcement group and as a SWAT team specifically, and to allow us to iterate on designing these things and to get feedback from them continuously. This is not quite a lab study, and it's not quite a field study. So it's somewhere in the middle. To give you an idea, like we will go with them to different training venues. I think they call this a shoot house. I don't remember where in Mississippi this is. It's not here locally. Basically, this is just an environment where they train and kind of train entering areas where they don't know what's going on, where they're expecting to face some type of threat. And so we spend time watching them conduct their operations just normally as they would as a team. And then we also have them do the same thing with robots to see how they would use those robots. And so then we take that data and work on developing those systems. We also have a facility here at Mississippi State that is a more controlled environment where we can actually construct different simulated environments for them to enter and to train in with robots and without robots. Let's see. And so that's just a shot of, so we have like kind of the full setup of, we can do a lot of different lighting configurations. We have a lot of audio zones, so you can put things like a dog is barking over here, and you can control that. You can also hear what they're doing and project different things and really control the environment and kind of create whatever you want to create. So this is not necessarily a strict lab study, but it's also not a real-world environment. So, let me see. I think this is a video, maybe. No, that was not a video yet. Okay. So that's the, this is, like we have, this is a breaching door is what it's called. So you can set this door up to have different strengths so that they can actually break down the door repetitively and do that with the robot or without the robot. And so also part of this is that they do have people playing roles as hostages or as shooters in their different scenarios. So I think this one's a video. Let's see. Yeah. So that was one of their, I should say they're using simunition in this. So it's just little plastic pellets that they're shooting in this case. That's no robot, no technology. And you can see this environment's kind of configured in a certain way. So here is a version of that where they're using a robot. So a robot is in front of them. And it's giving them a view, which you can see there. And so, yes, that is always quite a bit of fun. I'll show you just him reaching through this door. That's me. Getting the bird's eye view.
You got one right there.
And so they're using a Wii controller. And that's kind of an ongoing thing. And that's one way to evaluate your systems. So you saw a few different systems in that. I don't think did it show any with the robot? No, it didn't show any with like the strobe and bright lighting and sound and stuff. So another part of that is developing robots that can cause distractions or kind of immobilize a person with overwhelming light and sound. And so that's another aspect of that. So now looking more at controlled experiments. So these are more useful for looking at very specific things. They're very focused on systematic manipulation and what we would call high internal validity. So we want to be sure if we're running a controlled study that every person who takes part in our study experiences the same exact thing and that there are no what we would call confounding factors that are occurring. And that's something that we can do in a lab more reliably than out in the real world because we can control a lot more of what's going on. This can make this difficult to generalize at times. So we can find something in a lab and then later realize that it does not actually hold true in certain contexts outside of the lab. Controlled studies, controlled experiments are very time-consuming. They're very resource-intensive. These are what we would consider like modern scientific gold standard way of doing things. Highly controlled studies that can be validated very carefully. A controlled experiment is going to have a huge focus on making sure that every single bias that might exist, every single confounding factor that could be there is thought about and controlled for. And that the study is run in the same exact way and in a stable way over all participants. Otherwise, you're not going to be able to conclude anything. To give you an example of this, so this is a study that we run with kids and robots. So like in a controlled study, things as simple as, how we are laying out rooms, right? Like this chair needs to be tilted this way for all 200 kids that come through it. If it's tilted a few more degrees this way, I might have a problem later because the chair was tilted. And then that really doesn't help me with the other thing I was studying because now I'm dealing with the chair difference. Okay, it's a crazy example, but sometimes it can be something as little as that. So this is a lot of detail goes into this. A lot of careful work goes into this to make sure that things hold. So I'll show you some pictures of this environment. So simple things like you should think it. So this is like where a researcher talks to a child about their experience that they just had in the other room. You'll notice that like this is the researcher's chair, this is the child's chair. They don't sit across from each other because that can be a little bit intimidating at times. They sit at a very specific angle next to each other. If that changes, that can cause a problem, right, on how they're evaluating things. This is a room where they actually interview or talk to a robot or a human. In this case, you've got very controlled things. The room is very simple. There's not a lot to look at. Everything is always going to be exactly this way for every participant that runs through here. Another thing about these environments, this area is very tightly controlled. Everything is monitored that's going on in here. So like these two boxes here have Connect sensors in them. They're doing full 3D mapping of everything that's going on in the room, every facial expression, every piece of audio. It's all being captured in the same way so that it can be analyzed later. In this case, okay, so this is showing you this wall back here. So the child sits in this chair, and the interviewer is in this chair. When the interviewer, in our case, is a human being, so they're going to talk to the child about something. We talk to kids about sensitive topics like bullying, experiences they've had. When we run this with a robot, the robot is very consistent about what it's going to say. It's going to follow its script exactly. Okay, human beings do not do that naturally. And so because we're not interested in, if we were to let the human kind of naturally do their conversation, that introduces variance, a difference between the robot and the human. So this is a teleprompter in the background. So when there's a human interviewer, they're actually reading a teleprompter without the child's knowledge. And obviously they get very good at this. They're trained ahead of time. The prompter is just a backup in case they get lost. Also, because when the robot has to make a decision about if it should ask a child to explain something further, we actually make that decision at a remote location using software, and we need to make the same decision with the human. And they need to follow our decision and not their own. So that kind of thing goes into a controlled study, and that's just to look at that environment. And so this is where that interaction is controlled from. So you have a team of people analyzing things that are being said in real time, deciding what's going to be said, monitoring everything that's going on, and making sure that the study is consistent the entire time. And whenever the results for this are written up and they're sent out to be reviewed, you get questions about this kind of thing. People care about this, obviously, because you can't, or you don't want your result to be because of some extraneous thing that you didn't take care of. So talking about what should be measured when we do these things. It depends on the type of study, and the two big areas we have are qualitative data and quantitative data. So qualitative data being things like, how did this make you feel? And somebody says, well, it made me feel happy and like I was on top of the world and whatever. Quantitative data being things like ranking something on a scale, or how many times did they smile during the interview? Okay, that's quantitative data. What's important when we evaluate something and measure things, we want what's referred to as triangulation. So we want to use different types of data. So we would like to have some qualitative subjective data. So asking a person directly, how did you feel about this? We would like to have some quantitative data, and often we can do that with behavior. So how many times did they smile? Is something we can measure without them knowing we're measuring it necessarily. And then we'd like to have a third factor, and in some cases this can be something like, what was their heart rate like during this interaction? So physiological measures like that. And we want to be able to use all of those to judge an outcome. So talking about a few different ways we can do this. For qualitative data, interviewing is very common. You can have unstructured, structured, semi-structured interviews. So to give you an example, I just pulled this. This is a kind of a design study we did concerning designing therapeutic robotic dog TheraBot. And this is just a page from a study protocol that we used. It's an interviewer guide. And so we've got some questions here. This is a semi-structured interview. So we would bring in someone, we'd have them, interact with the robot, look at it, and then we would, go through these questions. And so these are all of the things that we need to know. Like we need to know, how should its head move? How should its tail move? All of these specific things. But we're not necessarily going to go through this in order. If the person answers these questions as they're just talking, we don't need to do that. So this is just an interview guide to help us, get through this study. So this is something that you would use as a tool when you're evaluating the system. So another way to do this, questionnaires. You can do what we would call forced choice, which is giving multiple choice, yes, no, agree, disagree. You can do scaled responses. So a common type of scale is called a Likert scale. You might hear it called a Likert scale. It's actually called Likert, and that's weird, but it is. And so that's usually like 1 to 10 or something. How strongly do you feel this way or that way? And then you can have open-ended responses, obviously. So I have some examples of some of those. I think this is from that same robotic dog study. So here's just a simple yes-no question. Have you ever received care for any type of trauma or traumatic event? Something we need to know about the person we're talking to. Here's one that's a Likert scale. How familiar are you with the idea of using a comfort object like a stuffed animal as part of therapeutic care? So these are background questions to try to gauge, if people who have certain past experiences have different insights than those who don't. Here's kind of something you would probably see in a lot of psych studies or even in HCI studies. So evaluating, describe, pick which best describes the robot. And so you've got counterbalanced things here: unfriendly, friendly, cool, warm, unhappy, happy. So you're just trying to rank those things there. Give you an example of kind of doing this with kids and these robots that we use to interview children. When we do studies with children, and I guess, anyone who does studies with children on anything, you'll find that kids are not real great at using a scale of 1 to 10 in a lot of cases, especially young children. And so we have to do a lot of open-ended responses and then code that data later. So this is just a verbally administered survey in this case. What did you think about? So in our case, our robots and our interviewers were both named Hannah and Zach. And it's not the Zach, it's a different Zach. And so that's why you see that there. But this is going through and asking certain questions about the interaction. Some of them are yes, no. Some of them are qualitative in nature. There's just a few more of those. So behavioral observations. You can do this directly. You can also do indirect observations. So pretty much every study we run, everything's recorded, at least with video and audio. We can analyze that data later. And then for robotics, we do a lot of different types of sensors, whether that's physiological sensors, heart rate and skin response and that kind of thing, or just things like how are you touching the robot, or are you shaking it, are you doing whatever, that kind of thing. Show you a little bit of a field study. This is stuff that I did at Texas A&M when I was an undergraduate. We would work with search and rescue responders with this robot, Survivor Buddy, that's meant to communicate with someone who's trapped in a bad situation. So we had a facility called Disaster City, actually, which has a wide variety of disaster scenarios available for responders to train on. So there are train derailments and parking garage collapses and all of these things built as they would be in real life. And then responders go out there and learn how to handle these scenarios, how to operate in that. We would go out with the robot and work with them on that. So in this case, in this study, this is someone who's playing the role of a trapped victim, and the robot is communicating with them. But some of the data that we extracted when we published these results is behavioral data. And so, like you can see, this is a timeline of what was going on. When did they speak to the robot? When did they gesture to the robot? When did the doctor on the other side of the robot do this or that? And so this is just purely extracted from looking at what happened on the video feeds and the audio feeds. Also mentioned physiological monitoring. So recording things that people tend not to have a lot of conscious control over, heart rate, perspiration, in a lot of cases pupil dilation can also be helpful. Just moving around, like fidgeting, facial expressions, all of that can be captured. Who participates in evaluations? A representative sample of users, not just college students that were easy to find. So this is really important. So a lot of psych studies have gotten a lot of criticism because a lot of psych studies just use freshman undergraduates because that's easy to make them be in their study. And that doesn't generalize so well. So when you do these things, you really need to find the user that's going to be your user. And so finally, what is the outcome of all of this? It informs the design of your product. It helps you understand fundamental aspects of design, and it identifies areas for further investigation. So some of the examples that we looked at, just to give you some of the findings that we found. So in that design study where we were looking at Therabot, the therapeutic robotic dog, we actually found that people had an opinion about what age group that platform should be used with. So you can see here, most people thought it would be, most useful for children in comparison to these other age groups. So that's interesting for us because it definitely tells us that we need to think more about how a child would interact with this, what the attitudes would be about children using it, things like that. When we looked at the bullying experiences study that I showed you, we actually found something really interesting, and that was that when kids talked to our human interviewers, they were less likely when asked about the interviewer and how comfortable they were telling the interviewer certain things. When it was a human interviewer, so the blue is the amount that did not mention anything about the interviewer being a positive protective factor. So something like, I trusted the interviewer, I could tell them secrets and they wouldn't tell anyone. They would help me if I were in trouble, they would not judge me, that kind of thing. They feel a lot more comfortable doing that with a robot. So that's something interesting. And for us, that's something that's an interesting ethical dilemma and question, as when you start to employ these devices, because one of the uses for these robots is for like police to conduct forensic interviews with children using a robot instead of a human. And so now you have major ethical and legal questions about the deception that's going on there, where the child is more likely to reveal something to this artificial platform. And so you find out things like that. You get qualitative results like that. These are just a couple of direct responses that kids replied. What could you tell them? We found a lot of children did not think that a robot would judge them, and that makes sense. But what's interesting is that the robot and the human followed the exact same script and said the exact same things. And so we start to look at this. We also start to look across ages of children and across different types of robots to see if that matters, and it does. But so you see a lot of interesting qualitative results like that. And so, so these are some of the things that we get out of this, and talking about, what we're going to do next. Looking at kind of the SWOT study stuff, you can see we go through an evolution of different game controllers. Like we found, we did a bunch of different ways of doing this, but we found that this Wii nunchuck controller is nice because it only requires one hand. And it turns out when you're on a SWAT team, you need a hand for the trigger always. So that's why that works. And so, we come out with kind of these findings, and then we continue going from there. So that's all I have today. Please submit that quiz 6 by tonight, and next time we'll talk about designing studies, and we will have a simple quiz about what we talked about today. Yes?
When you